Hello all, in this video of ScientiFacts, we are going to go through the concepts of force. The topics which we are going to cover are force, definition and effects of force, balanced and unbalanced forces, force and motion. So let us get started. Force. Here's an image of force. Let us understand after knowing the definition of force. Any action which causes a pull, hit or a push on a body is called force. So in this picture, these two people are pulling the rope towards itself. As it is a pull, it is called that they are exerting a force on the rope. Force cannot be seen, but it can only be judged by the effects it produces in various bodies around us. For example, the movement of air cannot be seen, but it can be felt or judged by its presence of indirect evidences such as the movement of leaves in contact with air, movement of dust particles in air, etc. To produce force, there should be a minimum of two objects to interact with each other, either in contact or in non-contact. We'll be seeing about contact and non-contact force in our upcoming videos. The SI unit of force is measured in newtons. So here's an image of the application of force. One boy is pulling the kite, another boy is throwing the ball in the net. Both are running and jumping. So these all indicate that they are applying force either by contact. The ball and the boy are in contact. The kite and the boy are in contact. So this is an image of application of forces. Next, we'll be seeing about the effects of forces. A force can move a stationary object. A force can stop a moving object. A force can change the direction and speed of a moving body. A force can change the shape of an object. All these indicate that force causes acceleration. Acceleration occurs when the object speeds up, changes direction, or when it is slowing down. When it's slowing down, it's known as deceleration, but deceleration is a type of acceleration. Now we'll be seeing how force and in the next upcoming videos we'll be seeing how force and acceleration are related. Here's an image showing the effects of forces. A man uses a force to move a stationary lawn mower. A footballer uses force to change the direction of motion of a ball. A cyclist uses a bigger force to pedal his bicycle and increase its speed. A baker uses a force on his dough to shape it into a curry puff. Now we'll be seeing about balanced and unbalanced forces in detail. Balanced forces. When a net force acting on a body is zero, then forces are said to be balanced. Balanced forces can only bring a change in the shape of the body. Balanced forces do not bring a change when the object is in a state of rest or in a state of motion. Example, in a tug of war, if all players from both sides exert an equal force, the rope doesn't move in either side. Because the forces are balanced, the net force is zero. When net force is zero, acceleration is also zero. When acceleration is zero, the movement is also zero. Not really, because when acceleration is zero, it can also be in uniform velocity. But when in a tug of war, the rope is static, it's stationary, so the movement is also zero. Here's an image showing the balance forces. So this is a block, a table. The weight is a type of force. It's pulling the block down, but a table using the normal flow force is pushing the block up. So due to the same amount of force, the forces get cancelled because they get subtracted and they become zero. Hence the block is not at all moving. We'll be seeing in detail about the types of forces in the next video. Now let's go to unbalanced force. When a net force acting on a body is a non-zero number, then the forces are said to be unbalanced. Unbalanced forces cause acceleration. We'll be seeing about this in detail in Newton's first law and second law of motion. When an unbalanced force is acted upon an object at rest, it causes motion. It is always not necessary for unbalanced forces to cause motion. We'll be explaining this in the force and motion section. When an unbalanced force acts on a moving object, it causes the object to accelerate. Here's an image of unbalanced forces. These two people are pulling the rope one with 50 newtons, one with 30 newtons. Remember, Newton is the SI unit of force. Hence, the rope is moving towards this side. Here's an image of a bird diving into the air. This is the weight of the bird is pulling the bird down, but air friction or air resistance is pulling the bird up. But since the weight of the bird is more, the bird is going down, or else it will stay static or it will go up. Here's a van or a car. There are 8 newtons acting on this side and 3 newtons acting on this side. 8. This is 8 newtons because 4 plus 4 is 8. Whenever forces are acting on the same side, we take the sum of the forces and we subtract it with the opposite side force to get the net force. And hence the net force is 5 newton on this direction. So the car is moving in this direction. Here's the propulsion of rocket. 300 newtons is going up and the weight of the rocket is 100 and it's bringing the rocket down. Since the net force is 200 in the upward direction, the rocket is going able to go up. Now here we come to the force and motion section. In this section, we'll be seeing the relationship between force and motion. First point, it is always not necessary for force to cause motion. For example, when we push the wall, does it move? No, it does not move because the frictional force and other forces overcome the force that we exert on the wall. So this is why I said that unbalanced force it's not necessary to cause motion because frictional force always keeps everything on in rest. So when frictional force is more, the object will be in rest, it won't be in motion. Second point, it is also not necessary for the direction of the net force and motion to be the same. For example, when we ride our bicycle and when we apply the brakes, what happens? We still go forward for some time until the frictional force overcomes it. In this, we can understand the direction of net force and motion need not be the same because when you apply brakes, the net force is on the opposite direction but the motion is in the forward direction. And in a period of time, when the frictional force becomes more, the net force and the direction of motion will become same. But till then, it's not the same. An object cannot apply a force on itself. There needs to be something or someone to exert a force on the object. This is not applicable to us because we have hands and legs to apply force on ourselves. But can a chair? But can a chair apply a force on itself? No, it cannot. It only when we push the chair, it only moves when we push the chair. So there needs to be some other thing for exerting a force on an object. So we have finally seen in detail about forces. Let us wrap up this class. And in the next video, we'll be seeing about the types of forces. In this, we'll be just focusing about contact and non-contact forces. And we'll also be seeing about Newton's first law, second law, and third law, and finally, law of conservation of momentum in our upcoming classes. Thank you for watching this video of ScientiFacts. Do not forget to like and subscribe our channel. Stay tuned, we have a lot more for you guys. Thank you.